Rules of logic is used to establish the truth of mathematical statements. So when we say argument, what we mean is a sequence of statements that end with some conclusion or a set of evidences where we can derive a certain conclusion. And what do we mean by a valid no argument? Okay. When we say valid, we mean that the conclusion or the final statement of the argument must follow from the truth of the premises or the evidences of the argument. Okay, so to deduce new statements from statements we already have, we are going to use the rules of inference. Okay. So suppose we have this statement. If you have a current password, then you can log onto the network. And you have a current password. Therefore, you can log onto the network. So how can we determine whether this statement or argument is valid? So that is, we would like to determine whether this conclusion, you can log onto the network, must be true given that the premises or evidences, if you have a current password, then you can log onto the network, and you have a current password statements are also true. So in order for us to determine the validity of this particular argument, we will have to look at its form. So in other words, what we are going to do is that we are going to represent the individual na propositions with the propositional na variables, let's say P or Q. So assuming P is you have a current password and Q is you can log onto the network. So we have these statements earlier wherein the first two na statements are the premises or the evidences, and the third na statement is our conclusion. Okay, so we know that given this, you have the current password is proposition P, and you can log onto the network is proposition Q. Following the if P then Q structure, then we can represent it into this form. P implies Q. And the statement number 2 is P. You have the current password, and our conclusion, Q, you can log onto the network, is therefore Q. Okay, so that is an example of a valid no argument. So what we did was, in order for us to analyze whether the argument is valid, we replaced the propositions by the propositional na variables. So after doing that, this changed the argument into an argument form. We saw that the validity of an argument follows from the validity of the form of the argument. So now we are going to summarize the terminology used to discuss the validity of arguments with the following definitions. So an argument in propositional logic is a sequence of propositions. So all but the final propositions are called the premises, while the last na statement or the last na proposition is the conclusion. So we can say that a certain argument is valid if the truth of all of the premises imply the conclusion. Okay, so what about the argument forms? So in order for us to analyze the argument, as we have mentioned earlier, we replace the propositions by the propositional variables. So this changed an argument into an argument form. Okay, so when we say that an argument form is valid, it means that no matter what, no matter which particular propositions are substituted for the propositional variables in its premises, the conclusion is true if the premises are all true. So in this example, what we did was we have shown an argument, and in order for us to show that this argument is valid, we replaced each na propositional statements with corresponding variables. And we have observed its argument form, whether it is valid or not. So if this certain argument form is valid, then we can say that this argument is valid as well. So from the definition of a valid no argument form, we see that the argument na form with premises p sub 1, p sub 2, and until p sub n, and q is valid when p sub 1 and p sub 2 and until p sub n implies q is a tautology. Okay, so the key to showing an argument is in propositional logic is valid is to show that its argument form is valid. So consequently, we would like techniques to show that the argument forms are valid. So what we are going to do is to develop methods for accomplishing this task. Okay. So in order for us to determine an argument's validity, so what we can do is identify the premises and conclusion of the argument. And an alternative is we can create a truth table showing the values of the premises as well as the conclusion. And then locate the rows in which the premises are all true. And this is what we consider as the critical rows. And for each critical row, determine if the conclusion is also true. So if the conclusion is true for each critical row, then the argument form is valid. So the problem with this approach is it is super tedious. For example, an argument form involves 10 different propositional variables. So if we use a truth table to show the validity of this argument, that means that we have 2 raised to 10. This is supposed to be 2 raised to 10. And that will result to 1,024 different rows. So fortunately, we don't have to resort to truth tables. So instead, we can first establish the validity of some argument forms using the rules of inference. So these rules of inference are all simple argument forms that we can use in order to construct more complex argument forms. So in the next videos, we are going to introduce the most important rules of inference in propositional logic.